Hello and welcome to this Python tutorial. Alright, so we just updated the memory after reaching the new state, and now let's take care of the next update. According to you now, what is going to be the next update? Well, basically, we're done with one transition. We updated the last element of the transition, which is the new state. So now it's like we're starting all over again. And when we're starting all over again, well, it's like, we are in this new state of the environment. And so what do we need to do now? Naturally, well, of course, it's to play an action, because we already got the observation of the new state. So now the thing that we have to do is play an action. And therefore, what we need to do now is, of course, use the select action function to play the action. So let's do it. Let's create a new variable action, and let's play the action with the select action function. So I'm taking, well, first self to specify that the select action function is a method of the object of the DQN class that will be created. So self.select action. Here we go. Self.select action. And then, of course, since the select action function takes the state as input, because of course the select action function will return the output of the neural network when the current input state entered the neural network. So we have to input the input state here. And since that's the state that we just reached in the environment right now, well, the input state is, of course, new state, because the state that we just reached at the time we are right now is new state. So in the select action function, I'm inputting new state. All right, so with this line of code, we simply play the new action after reaching the new state. Okay, and now that we played an action, well, we get the reward, and therefore we get a feedback with the reward. And therefore, if we have more than 100 elements in the memory, well, it would be time to learn. And therefore, what we must do now is what logically comes after selecting an action, which is, of course, to learn. The AI needs to start learning if it is doing the things the right way. And now, since it just played the action, well, we're going to make the AI learn from its actions in the last 100 events. But before we apply this learn function, we have to make this if condition to make sure that we already have reached more than 100 events, because, we're learning from the random samples of the memory. We have this huge memory of 10,000 elements. We're taking some random samples of the memory of 100 elements, and the AI is learning from the informations contained in this sample of 100 random transitions. So let's just make this if condition to make sure that the number of elements of the memory, self.memory, and then be careful, just a little trick here, self.memory is the object of the replay memory class, but then the replay memory class has an attribute, which is memory. So in fact, we need to take self.memory.memory. The first memory is the object of the replay memory class, and the second memory is the attribute here, self.memory. So if the number of elements in the memory is, well, we want it to be larger than 100, then colon, and then what happens? Well, we can learn. But before learning, we need to get this random sample of 100 transitions, and this we can get with the sample function. And since the sample function returns the different batches, the states at time t, the states at time t plus 1, the actions at time t, and the rewards at time t, well, what we need to do now is create some new variables, which are going to be the batch of the states at time t, the batch of the next states, the batch of the rewards, and the batch of the actions. And we can simply give the same names as we gave for the arguments here, and paste that here. And these variables will be equal to what the sample function returns, because it returns exactly these batches of the states, next states, rewards, and actions. So what we simply need to do now is get first our memory object, and then from this memory object, we're going to use the sample method, which will take as input, well, the number of transitions we want our AI to learn from, that is 100. That's why we made sure that the memory had more than 100 transitions. So it's going to learn from 100 transitions of the memory. So the learning will be much better. And so now let's make this learning happen. Well, since the learn method is a method of our DQN class, well, we need to access this learn method from the future objects that will be created from the DQN class, and therefore what we need to take is self. So self refers to that object of the DQN class, and then learn as this learn method. Learn method to which we input, of course, these guys here. The batch state, the batch next state, the batch reward, and the batch action. So these are our batches sampled from our memory. And we get 100 of them. Because we have 100 transitions, and from these 100 transitions, we take 100 states, 100 next states, 100 rewards, and 100 actions. So let's paste that here. And there we go. Now the learning will happen. It will happen from all these random batches. Perfect. And now what we need to do is the very last update. After, reaching a new state and playing an action, well, we got the action to play, but we still didn't update the action. That is our self.lastAction variable. So let's make sure we don't forget this. Let's do it right now. We will update the last action, self.lastAction equals, and of course, action. The action that we just played here with the select action function. All right, so now the last action is updated. Then same for the new state. We reached the new state, but we haven't updated the last state yet, because of course the last state was before the state at time t. But since now we reached the new state st+1 at time t+1, well, the last state becomes this new state here. And therefore we need to update it as well. Self.lastState equals our new state. There we go. And now what do we need to update? Well, there is only one thing left. That's of course the reward. And the reward is exactly the reward we get in reality. So that will be the argument of this update function, which, if we make the connection to our map, will be the last reward, that is, the reward we get right after playing the action in this reached new state. So if we go on to some sand, this last reward will be bad, -1. If we get further from the goal, we will get a slightly bad reward, -0.2. If we get closer to the goal, we will get a slightly good reward, 0.1. And if we get too close to one edge of the map, well, that will be a bad punishment. We will get -1 for each edge. So that's the last reward we get in reality. That is the one that happens for real on the map. And this will be the argument of the update function. This last reward here, that's exactly this one. And so since this is the argument of the update function, well, that corresponds to this reward here. And therefore, our self.lastReward variable initialized at the beginning in this init function becomes the new reward we get in reality, that is reward, or that's the same last reward. All right, so now we updated our last reward. And now, since we just got our last reward, well, we can now update the reward window. You remember the reward window we initialized here as one of the variables of the object of our DQN class. That's the window that's going to keep track of how this training is going by taking the average of the last 100 rewards. So, it will be like a sliding window showing us how the mean of the rewards is evolving. And so since we just got our last reward, well, we can update the reward window. And so how do we update it? Well, we simply need to append this last reward to the window. And therefore, what I'm going to do is take my reward window, self.reward window, here it is. And then I'm going to use the append function. And inside the append function, we need to input the element we want to append to the reward window. And that's, of course, the reward. All right, perfect. And then since this reward window is going to have a fixed size, it's not going to be a growing window. It's going to be a window of fixed size sliding with time to show us the evolution of the reward. And so now we need to decide for a size of this window. And it's simply the number of means of the rewards we will have in this window. And so, for example, let's get, the last 1,000 means of the last 100 rewards. And so to make sure of it, we're going to add if, then len, then we take our reward window, and we simply add here if the number of elements in the reward window is larger than 1000, well, what we want to do is delete the first element of this reward window, and the first element of this reward window has the index 0. Alright, and now we make sure that this reward window will never get more than 1000 elements. That is 1000 means of the last 100 rewards. That's perfect. This will be a window of fixed size so that we can see if the mean of the rewards is increasing, and therefore if the training is going well, and accordingly if the car does what we want. Perfect. And now one tiny little thing to do left. According to you, what is it going to be? Well, remember, this update function not only updates the different elements of the transition in the reward window, but also it returns the action that was played when reaching this new state. That's why we have in the map action equals brain.update last reward last signal, and therefore it's supposed to return something. And the something it is supposed to return is of course the action. So the simple last thing we need to do here is just return action. The action that was just played when reaching the new state. And that's it. Our update function is ready. It's going to do all the required updates and it will return the action when reaching the new state. That's perfect. That was the last difficult action to make for all this AI process. Now the rest will be kid stuff. We will just make a score function to return the means of the rewards in the reward window. Then we will make a save function to save the brain of the car whenever you want to quit the application and go back to it. And of course, since you want to be able to load the brain of your car when you get back to it, get back to the application, well, we will end up by making a load function, which will load your model after you saved your model with the save function. So 3 functions to do left, but it's going to be simple, and then we'll have the most exciting section of this first module, that is the demo. We will see if the AI works, we will see if the car reaches the goals, and we will see how we can improve it. And then eventually you will have built your first AI. So I can't wait to start the demo. Let's make these 3 functions first, and until then, enjoy AI.